The overall goal of this procedure is to fabricate high aspect ratio nanogap electrodes using nanoskiving. This is accomplished by first depositing a thin gold film on a silicon wafer and transferring it to an epoxy substrate. The second step is to form a self-assembled monolayer of alkane thiols on the metal film. Next, a second film of gold is deposited that is offset with respect to the first. The final step is to section thin slices of the structure with an ultramicrotome.
The main advantage of this technique over existing methods like photo or e-beam lithography is that thousands of nanogap electrodes can be fabricated with sub-nanometer resolution on demand and positioned on any arbitrary substrate without the use of a clean room or any conventional photolithographic processes. The shape and aspect ratio of the nanogaps allows them to be directly addressed in a probe station without any intermediate fabrication steps such as defining contact paths.
To start the fabrication of a structure, begin with a technical grade 3-inch silicon wafer. Treat it in an air plasma cleaner for 30 seconds. Next, expose it to perfluorinated silane vapor for 1 hour. After the exposure, use a Teflon mask appropriate to the desired length of wire to evaporate a layer of gold onto the pre-treated wafer. The thickness of the evaporated layer, 100 nanometers in this experiment, defines the width of the wire. With the evaporation complete, cover the entire wafer with approximately 8.5 milliliters of epoxy